Good afternoon, judges. My name is Joy Skaggs, and I'm here to discuss with you my analysis on the time effectiveness of speeding while driving a vehicle. Now, this project I did in my Honors Physics 1 class, and I took inspiration from the fact that obviously speeding results in more fatal crashes. But does speeding actually save you time? And this was also drawing from a study that the U.S. Army did in 2022, where they found that time is not necessarily saved by going faster. I thought that this was an interesting result, so I decided to reproduce their methodology. Here in Table 1, you can see their various variables they used to do calculations with Equation 2. So I also did these calculations, and I compared my results to their results. And finally, I wanted to also consider the real-world limitations that there might be with an experimental portion. So here in my theoretical data, you can see that all these different trips ended up getting a logarithmic line of best fit. And all of these logarithmics are decaying, which makes sense. As you go faster, you're going to take less time to get wherever you're going. Now, my car taps out at about 140 miles per hour. So if we take the limit of all these different functions as they approach 140 miles per hour, you'll see that we get that it takes 0 time to get wherever you need to go, which doesn't make sense. And that's where this theoretical data starts to break down here in Figure 1. But another thing that you can find is that if we just consider the initial road speed and how fast you're going on that road, it doesn't necessarily matter how far you're going. You're always going to save a maximum of whatever percentage of time. For example, on a 25 mile per hour road, if you go 20 miles over the speed limit, you're only going to save a maximum of 44% of the time. And this was what the Army found with their results. You can only save a maximum percentage of the time. And again, this is in ideal conditions where we're considering the acceleration is constant. However, when I did some experimental trials, following all the laws and safety regulations, of course, we can see that the average velocity in Figure 3 here is not constant, which leads to interesting outliers like this 3-mile trip that took more time than a 6-mile trip did. And then again, we can look here in Figure 4 and Figure 5. These are both 3.21 mile trips, but you can see the average velocity for the trip in Figure 4 was constant longer than the average velocity in the trip in Figure 5. And because both of these, even though they were on the same distance, the Figure 4 trip took less time. And again, we can even see that this holds true for long trips. Here in Figure 7, this 50-mile trip had long stretches of time with a constant velocity, compared to this 27.5 mile per hour trip, which had some stretches but a lot of breakage in the velocities. And as we can expect here in Figure 6, the durations for each of these trips, the 50-mile trip took less time than the 27.5-mile trip. And again, we can see that's because that 50-mile trip had a higher average velocity than the 27-mile trip did. So, in conclusion, we can see that the theoretical data values that I got, they match with the U.S. Army study, allowing me to conclude what they did, that you can save a maximum amount of time with speeding, but our experimental data shows that other additional delays in the roads, like turns or blockages or other cars that you have to be mindful of, mean that the average velocity is not constant, and therefore you can never actually reach that theoretical time that you could save. Additionally, there's some other consequences of speeding, such as getting a speeding ticket, which can cost upwards of $100, and with each speeding ticket, your car insurance increases, thus making it more expensive to drive on the road. But more important than the cost of money is the cost of human life. In 2022 and in 2023, nearly a third of all fatal traffic accidents were because of speeding. So when you're traveling and you see you're about to get to work a minute late, remember that it's better to take that extra minute to get there on late than it is to lose your life in a minute. Here is my bibliography with all of my sources, and then I'd like to thank my advisor, Dr. Jessica Young, for all of her support. Thank you very much for listening. Have a good day.